Hello everyone. Today I am going to discuss on the topic calculations of enzyme activity. Unit of enzyme activity. It is used to measure total units of activity in a given volume of solution. Specific activity. It is used to follow the increasing purity of an enzyme through several procedural steps. Molecular activity is used to compare activities of different enzymes, also called the turnover number or TON. Now comes some classical unit. Unit of enzyme activity. Micromole substrate transformed per minute. Specific activity. Micromole substrate per minute milligram of enzyme equal to unit per milligram of enzyme. Molecular activity. Micromole of substrate per minute micromole of enzyme equal to units per micromole of enzyme. New international units. Unit of enzyme activity. Mole of substrate per second equal to kcal. Specific activity. Mole of substrate per second kg of enzyme equal to kcal per kg of enzyme. Molecular activity. Mole of substrate per second mole of enzyme equal to kcal per mole of enzyme. Now let us see two examples. The first question tells us the rate of an enzyme catalyzed reaction is 35 micromole per minute at substrate concentration equal to 10 to the power minus 4 mole, where Km is equal to 2 into 10 to the power minus 5. Calculate the velocity at substrate concentration equal to 2 into 10 to the power minus 6 mole. Now let us see the answer. First, calculating Vm using the Michaelis-Menten equation. V is equal to Vm into substrate concentration, that is divided by Km plus substrate concentration. Or the rate of an enzyme catalyzed reaction is 35, so we can put 35 in the place of V, and so 35 is equal to Vm into 10 to the power minus 4 divided by 2 into 10 to the power minus 5 plus 10 to the power minus 4 is equal to Vm into 10 to the power minus 4 by 1.2 into 10 to the power minus 4. Vm is equal to 1.2 into 1.2 into 35, that is equal to 42 micromole per minute. Then calculating V. V is equal to 42 into 2 into 2 into 10 to the power minus 6 divided by 2 into 10 to the power minus 5 plus 2 into 10 to the power minus 6. That is equal to 84 into 10 to the power minus 6 divided by 22 into 10 to the power minus 6 is equal to 3.8 micromole per minute. Now the second example. An enzyme 1.84 microgram and molecular weight is 36,800 catalyzes a reaction in presence of excess substrate at a rate of 4.2 micromole substrate per minute. What is the turnover number in minute inverse? And what is the turnover number in second inverse? Now the first part of the question, that is turnover number in minute inverse. The solution is micromole of enzyme is equal to 1.84 microgram divided by 36,800 microgram per micromole, that is equal to 5 into 10 to the power minus 5 micromole of enzyme, and the turnover number is equal to 4.2 micromole per minute divided by 5 into 10 to the power minus 5 micromole, that is equal to 84,000 minute inverse. That is the answer of the first part. And what is the value of the turnover number in units of second inverse? Now the turnover number of enzyme is equal to 84,000 minute inverse into 1 second inverse divided by 60 minute inverse, that is equal to 1400 second inverse. And that concludes my presentation. Thank you.